All right, so today we have Jay Alammar, Director and Engineering Fellow at Cohere, which you can find at cohere.com. He's also the author of an O'Reilly book, Hands on Large Language Models with Martin Grutendorf. So, if someone I know from BERT Topic, the BERT Topic Library. So, Jay, welcome to the podcast.
Thank you so much. Delightful to be here with you.
Yeah, so you were known as an educator and blogger for a long time. But now that you are at Cohere and you're a director there, so what has changed in how you think about teaching and building with LLMs?
Yeah. So it's this is now my fourth year. I finished 4 years with Cohere. So I've been with them for quite a while, and I really love the opportunity because it's a chance to sort of join the team earlier on when language models were just in the lab. So one of the co-founders of Cohere, Aiden
So
Gomez, is
four years ago, this precedes ChatGPT.
yes, we're
Yeah.
talking around the time of GPT-3, just about. So one of the co-founders of Cohere is Aiden Gomez, who's the one of the co-authors of the Transformers paper, and that comes maybe 1 or 2 years after I wrote the illustrated Transformer article blog post. It's been sort of read by millions. It's sort of how most people sort of come to know about me. And for the book, we updated it for how models look. But I'm a student of how this technology grew out of the lab and sort of went into industry and went into practice. And being able to work in a company that's actually doing that and helping companies adopt these technologies for business applications has been w- very interesting and educational for me. And that's a little bit of what I use to teach, and what I use my online writing and book writing to basically uh, learn in public. That's been my greatest life hack.
So I assume there's a big difference between what you describe as learning in public and trying to get yourself up to speed on your own, and on the other hand, teaching companies and teaching teams within companies. So what's the big material difference there?
So if you're learning and catching up on your own, you have to run through so much content and so much news, and you have to mute a lot of it as well. So this is an industry that moves extremely fast. Nobody can sort of catch up. Everybody's overwhelmed by the speed and the pace of how new developments happen in AI. That includes everybody in companies, and so for adoption, the important thing is to filter a lot of that and to sort of see what actually works in the real world and what patterns are important across use cases or across industries, and sort of collect those and write about those or describe those. That's why it's something like, of all the applications and use cases, for example, that people are using out there, something like retrieval augmented generation, let's say, proved itself as one uh, application paradigm for how people should be able to use language models in the real world. So a lot of it is helping people cut through the hype and actually get to what's actually useful, and understand a little bit of, or raise the AI awareness, because this tech is changing so much in technology, in jobs, in productivity, and so there's a level of literacy, AI literacy, I feel that people sort of need to come to grips with.
And I assume people in companies they want to learn things that are contextually relevant to them, right? So if you're in finance, you want material that will help you work in, I don't know, Bloomberg and those types of data sources, and also material that's aware of the regulatory environment that you operate in. So how much customization do you have to do when you talk to these teams?
Yeah, so the first thing when ChatGPT came out, that's when most people sort of started being able to understand what this type of technology is capable of doing. And there were multiple lessons that the industry needed to understand first. So first is, don't think of the chat. experience as the first thing you deploy with large language models. You should be using them first for simpler, more predictable sort of use cases, things like summarization or extracting maybe the names of people from a contract, or and then thinking about these as individual sort of building blocks to build an application with. So don't start with the chat, and don't. I think it's unfortunate that the name generative AI sort of grew to be used, because a lot of the most interesting things that AI can do is not generative in nature. It's the representation with things like embeddings that enable these models to do better classification, better categorization, better clustering, and enabling people and companies to make sense of vast amount of data. Um, and the next lesson that also needed to be learned is to not rely on a model's information. So in the beginning of 2023, in the media, there were so many news stories and discussions about how the model is a search engine, and people are asking the model questions and sort of expecting the results to be truthful. And they were surprised when the model can be confident, even if it's not speaking about something that is actually true. So hallucinations took a while for the common understanding of people to come to grips with. And one of the first solutions that are continues to sort of be developed for that is retrieval augmented generation, where you before the answering phase, what we call grounded generation. Uh, you retrieve some sort of context that hopefully contains the answer or contains the information that is um, will enable the model to sort of be grounded on. And then in the case of companies and enterprises, that would most likely be from internal data sources, which I raise the next question of data security and data privacy. And so companies um, require the model to sort of to be, they don't want their data to be to leave, let's say, the security of their own network. And so that's where private deployment of models becomes a priority for companies, where the model comes to the data does not cross the boundary of the internet and hit an API somewhere. And so data security and data privacy became some of the most important things for companies deploying that. And then with that, they start to deploy their initial use cases, which can be something like retrieval augmented generation, grounded on their internal data. And then that raw system can answer questions to a specific level of difficulty, but with more difficulty, the system needs to be more and more advanced. Maybe the system needs to search for multiple queries. Maybe the system needs to do things over multiple steps. And with that, we start to see RAG systems evolving into what we now call LLM backed agents.
One of the things about RAG that we all learn early on is just because you feed something in the context window doesn't mean the thing won't hallucinate, right? So it'll
Yes.
still hallucinate. And then the other thing that seems like people have developed more an appreciation of is why not supply even more context into that context window? So people started talking about things like graph RAG. Now there's a new buzzword called context engineering. But
Yep.
my thing was, any kind of structure that you can feed into the context window, you should. So, are there specific trends there that you're seeing people are doing more of? So, I was a big I got excited, Jay, a little bit about GraphRag, but then I realized, oh, this is actually hard for companies because not many companies have knowledge graphs, and creating a decent knowledge graph, they're starting to be tools, but we're still not there yet. So, what are some of the trends within the RAG world that you're seeing that are kind of actually you're seeing real teams really using them?
True. To your first point of, yes, if you provide the context, the model might still hallucinate. That's alludes to a new nature of this kind of software that sets it apart from previous generations of software, which is the answers are probabilistic in nature, and the same model that can answer your questions 99% of the time correctly. In the last sort of time, it might.
Or the models are just they are black boxes and they're opinionated. So if you ask it a question, you put the information in the context when the model may still think, hey, I saw something in my pre-training data. Let me opine.
Yes. True, true, true. And like if you're creating or training a model, there's that trade-off of how much do you want to force the model to answer from the context versus uh, following, let's say, general instructions or what is common sense, for example. So if the context tell it that gravity pulls people up instead of down, do you want that context to override the common sense that you understand? So that's, let's say, there are trade-offs there
Oh, that's a
uh,
good point. Yeah, yeah, yeah.
for
Because your context might actually be you're feeding conspiracy theories in the context window.
you can, yeah, you can, as a model creator, you always think about generalization and how the model can be the best model across the many sort of use cases that people will want to deploy it in. The evolution of RAG, um, there we touched on a couple of these. So um, there are multiple levels of difficulty and, let's say, knowledge seeking behaviors that can be built into a RAG system. So we said the first one is just to search one data source and get, let's say, the top 3 or 10 documents and add those to the context and provide them to the model. That's a raw, simple first kind of RAG system that you want to deploy. Then RAG systems can be improved by saying, okay, don't search for the user query itself or the user question, because that can be confusing or long and contains information that might confuse the search system or the database. Give actually the question to a language model to say, what query should I search for to answer this question? And so that was one of the first developments to these RAG systems, was a step called query rewriting. And now here, the generative model became a part of the search and retrieval stack, in addition to, let's say, other language models like embedding models and rewriting models that are also improving these. And then for the model to improve its information gathering, give it the abilities to search for multiple things at the same time. So that's the idea that's called multi-query RAG. So if I ask the model, compare for me the financial results of NVIDIA in 2020 versus 2023. A simple system would want to have those two pieces of information in one document. But a more advanced system will say, okay, let me search for NVIDIA 2020 and let me search for NVIDIA 2023. And then I'll get these two documents and then synthesize them and get the information that I need from both. And so that's where a model does in one step can search multiple queries. And then there are kinds of questions where the model needs to ask multiple questions or queries successively in sequence. And so a question like that is if I say, who are the top car manufacturers in 2024, and do they each make EVs or not? The model here, the best, let's say, process to do here is to first answer the first question: what are the top who are the top car manufacturers? And then you get that list of 20 companies, and then you send a query for each one. Does Toyota make an EV? Does Volkswagen? And so now you're starting to see this agent building this behavior, and so that was, let's say, the evolution that led to these systems. And some of the top features are the ones that we described: query rewriting, and then having the ability to use tools like search engines, and the ability to decide when it's gathered enough information to answer a question confidently or not, and the ability to do things successively across multiple steps. And that's what sort of brings us to, let's say, the RAG information agents that we have now. One thing to your point about context.
Yeah, yeah. Earlier in the pipeline, right? So as you actually as you take your whatever they are PDF files or whatever, you actually study them, right? So what are their chapters or their abstracts or their whatever footnotes, and you take advantage of all of this information somehow because you have better context. Like I said, so the kind of the golden nirvana here is a knowledge graph, but let's set aside the fact that no one can build a decent knowledge graph yet, right? So so what are because I myself I'm beginning to do this, and also I'm hearing teams kind of taking advantage of that earlier part of the pipeline, which is basically let's exploit the fact that the person who put together these documents
Yeah.
did something. We should take advantage, right?
True. This is a great design pattern we're starting to see more and more of when you onboard a new data source, uh, give the model an onboarding phase where it can collect information, store it someplace that help it t- interact with this. We see
Yeah,
this, for
yeah. I mean, at
example,
the highest level, metadata, even, right? So
100%. So we see a lot of metadata with, for example, agents that deal with databases. So grounding on databases is databases where most company data live. Uh, and so when you connect, or let's say onboard to a database system, it would make sense for you to give the model a sense of what are the tables attached, what columns do they have, what kinds of data. So creating some sort of a snapshot of that. You see that also with repositories. So with products like Cursor, or these IDEs that employ these code agents, uh, when you onboard the model to a new, it would make sense for it to sort of, or for you to give it a markdown page that says this code base uses these kind of, this is the tech stack that it's using. These are the testing frameworks that are used, and for the model to pull that into its context as, this is a brief snapshot of this, and to say, maybe after implementing every large enough chunk, do a check-in, but after running the tests, and this is the command to run the test. So all of this helps the model, because up until now, regardless that we have models that can fit 1 million or 10 million tokens, managing that context is still a very important.
and also it's not if your retrieval actually gives you the right information, why would you stick 1 million tokens in the context? That's expensive and that slows things down. And by the way, one of the things that people are noticing is that these LLMs seem to behave like us, which is they read the beginning of the context and the end, right? So the beginning of the document and the end. So a lot of things they may miss in the middle anyway.
Yeah.
So Jay, I guess I don't want to be unfair here to the graph rag people, but I want to ask you: Have you? Are you hearing people doing graph rag, or is it me that it's more of a thing that people write about and have like basic tutorials, but people and companies, very few are actually going down this road at the moment, at least, right?
Yeah, I don't have, let's say, direct experience with it. I haven't seen much of it sort of in the circles that I sort of look at.
What about the people you talk to? Are they asking for it?
I cannot cite sort of much
Clamor.
clamor around it. Yeah, I've heard of, let's say, uh, lots of interesting developments on the graph side, but that's also there are lots of interesting developments across other areas of language models and machine learning.
Obviously, the
Agentic
people
systems.
talking about it are the graph people like Neo4j. They have a whole DevRel team going to all these conferences talking about GraphRag. I'm the chair of many conferences, and one of the patterns I see with a lot of these emerging technologies is you get excited, and then a year in, you realize the only people talking about this are the vendors who are selling something in this area.
Yeah, it's a common pattern to come across. It's hard for anybody to predict what's going to be popular or not.
By the way, so evaluation, right? So you're talking to a lot of companies. I'm beginning to tell people, by the way, your eval is IP. Your eval is one of your sources of intellectual
Yeah,
property, right? So the eval data sets, how you do it, your processes.
sure.
So I send you to a company and they ask you for advice for eval, obviously big topic. But what's the step one and two and three? What are the first few things they should be doing?
Yeah, that's one of the first areas where companies should really develop internal knowledge and internal capability.
So do you agree, Jay, that eval is IP, right? So it's core intellectual. To me, it's core intellectual property. I mean,
Yes,
if you
for
do it
sure.
well, that's what would set you apart from your competitors.
Because like it's how you're able to tell which vendor is better for your use case and which model is better for you for your use case. And it's in the realm of software, it's akin to sort of the unit tests that companies have for their code base, because you needed you need it to sort of be able to differentiate and really understand what use cases you're after. And if you haven't defined those, you're not going to be very successful. So you really set yourself up for success if you define the use cases that you want. You gather internal examples of your exact internal data that the you want the model to behave on, and that can be a small data set in the beginning. It can be 10 or 50 or 100 examples, but that will give you so much direction in terms of choosing.
And you might that might force you to learn to develop kind of your process too. Like when do you do eval? When do you send something to a person, or
Yeah,
when do you send something to another model? Right. So
true.
yeah.
Sure. So it that grounds people's experience and I guess expectations when you actually know the kind of input and output that you're expecting to the model. That gives people the ability. But then you get all the benefits of unit tests. So when the next version of the model regresses on a specific capability, you have the test to actually capture it and sort of make sure that maybe you change the prompt in a specific.
So with that said, what's the level of sophistication of a regular enterprise in this area at this point?
Well, we see people developing quite quickly because let's say the pickup in language models is tremendous. There's so much interest across from the top leadership of companies. And so it's an area where people or where companies are sort of catching up and investing in it as well. We're seeing sort of a lot of um, adoption of things like tool use and RAG, and sort of defining lots of companies defining their own tools with MCP being big right now. These are all sort of big topics for a lot of these models. But it's always a good thing to continue to sort of advocate for, just like continuing to advocate for good software engineering practices.
So we talked about RAG, right? So what are some of the, I guess, patterns or use cases that are common now that that you're seeing people happy about that it's delivering on the ROI?
Yeah, so RAG and grounding it on an internal company data, that's one area where people can sort of start to really see a type of product that was not possible 5 years ago. They're interesting, and the level of expectation continue to rise with time. So once a company, for example, deploys their RAG model, uh, other things come to mind like, okay, multimodality. Now we need the model to be able to answer us and sort of have a sense of images, of audio, of video, for example. And it depends on, so multimodality is the next horizon, I think, for
So where are we on multimodality in the enterprise? Is it still 90% text?
so it's very important, specifically if you talk about companies that rely a lot on, let's say, PDFs, or there's a good
Yeah,
number of.
there's all sorts of charts and images in there, right?
Yeah. And then if you're in the medical field, there's a lot of.
Medical imaging.
Exactly, there's a lot of medical data, satellites, all of that. And so we've seen something that got quite a bit of pickup is where embedding models can also support embedding images and sort of imposing images and text into the same embedding spaces, and so the retrieval can come and cut across both.
Video and audio are always kind of the orphans in this.
Yeah, video is more difficult because it's
More compute intensive for one, right? So
100%, yeah, and only like very specific maybe media companies um, are, let's say, perhaps leading the charge of the demand on that end. But for to say across and audio, I'm expecting or anticipating lots of developments for audio this year. It hadn't really caught up to text, but I'm expecting um, so many audio product to come to the market.
so in the enterprise, One of the earliest use cases, obviously, is software development and coding. Is this an area that you folks are working into?
Yes, that is my focus area. I think a lot about code generation agents and deploying them and let's say developing them and their capabilities. Yeah.
And at this point, uh, I would say that most developers are open to using AI assisted tools. If anything, the most junior developers are probably the most open to it. The senior developers are also open to it. It's that mid tier, mid career are somewhat resistant in my mind. But what's your sense of the level of acceptance or resistance?
So I advocate for people to try out the tools and more to understand where they're strong, but also to understand where they lack and how they develop. And the tools now are different from the tools a year ago, and in a year from now they'll be also quite different. I've found them very useful, but you need to own to assert ownership, I guess, and to also understand how LLMs evolved from being writers of functions where you tell it write me a function that does this exactly like a lead code problem, which is if you look at how the evaluation benchmarks for code, let's say 2 years ago or 3 years ago, like something like human eval, it was all like these kinds of lead code type problems. Here's an array, write me a function that sorts it in a specific way, for example. But more and more you're starting to see these more advanced software um, engineering where the model needs to solve much more, let's say, larger problems across multiple steps and stages, where lots of models that are released now are evaluated on something called SWE bench, SWE
Yep.
bench. That's the benchmark where the input that you give to the model is a GitHub issue. And then you're like, go and solve this GitHub issue. And we'll verify it once the unit tests that we have pass on it. And that's a much more difficult problem.
Claude Code is quite good at this, but it will just brute force the hell out of and it'll burn through a lot of tokens and it gets I mean, I guess if you're working in a company and it solves your problem, that's fine, but it can get expensive, which actually is one of my pet peeves, Jay, is that these tools are great, but then we're getting to the point where the only way I can write software is if I'm connected to the internet, right? So if I'm on a plane and I get disconnected, suddenly now I feel like I have one arm behind my back, right? So, but I'm assuming that the smaller models are also improving, and then we'll be able to do our work offline.
100%. Yeah, no, really excited about smaller models. They are catching up so quickly. A lot of what you can do with the biggest models 2 years ago, now you can do with a model that's maybe 2 billion parameters or 4 billion parameters. That will be more and more sort of pushed to the edge. And especially the more defined the scopes of the problems sort of becomes. Uh, and so, yeah, I share your excitement for offline.
Obviously, one of the buzzwords is agents that you alluded to earlier, right? So I'm assuming most people are kind of in the early phases. They're doing simple, very task specific agents. Maybe they have multiple of these task specific agents working in parallel, but I don't see a lot of. I think the whole multi agents, where the multi agents are talking and coordinating among themselves, I don't think that's quite there yet. But you tell me what you're seeing.
Yeah, the maturity is sort of still evolving, and we're in early days for LLMs as a whole, and then for agent systems specifically. Yes, let's say the production rollouts are going to take some time until these become, let's say, robust systems. But people are seeing, like, if you deploy them in the right context and the right sort of situation, they can, under the right user expectations of what to take from the model and sort of what uh, they can solve so many problems that were not sort of expected. So when built in the right context with access to the right tools and information, they can be quite useful. But then the end user sort of remains the final sort of expert, and the model should show the user its work and its reasons for uh, saying something, and let's say its sources for the information that it gathered. So the end user becomes, let's say, the final arbiter of the information that is. So the more we sort of empower the user, I think that's something I'd love to sort of continue to advocate for.
Yeah, I tell non-tech people you're already using agents if you're using one of these deep research tools.
Yes.
You can think of them as an agent, right?
100%. So advanced RAG systems have become agents. That's one case, and then deep research is maybe one of the more mature type of deep research systems as well, which is just doing RAG, like really advanced RAG that is really deep. Instead of searching once, it tries to search 30 or 40 times and build up a much bigger document.
Yeah, and you can imagine. Actually, I noticed that there's finance startups who are basically building sort of deep research tools for analysts in the finance industry, but they're essentially agents because they're specialized, right? So maybe one agent is going for earnings, another for another kind of thing, but and then they kind of have a data fusion in the end. But so you can imagine multiple of these agents for knowledge work. That's 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 basically here now, I think.
Yes, and that's, I think, the pattern for multi-agent that is maybe the more organic growth out of single agent, where the single agent can delegate, let's say, this very well-defined task to a sub-agent that goes in and then
and,
is there.
and I know developers who have multiple instances of Claude code doing something that they will then bring together, right? So that you can think of those as agents as well, right?
True, true. Yeah, I think we're at the beginning of this discovering and exploring the various, and we don't really have the user uh, interfaces and the systems that have sort of evolved enough for us to make the best out of this. And for code, it started out in the IDE, and then some of the earlier systems that I saw that utilize the command line, where it's useful to actually have the AI in the command line, is a tool called Aider. It's an open source software, which I would assume was the inspiration for Claude Code. But it's definitely a good a good way to augment AI in the IDE for code.
Yeah, yeah. There's new generations of the terminal, even
Yeah,
warp.dev, or new generation of
yeah,
notebook, Marimo, right? So
100%
that are incorporating many of these developments, right?
true. And then code extends to beyond what software engineers are using. So the general user requires some level of code ability in the agent, even if they're not reading the code. If you tell the model to give you a plot, a bar chart of something, the model is writing, let's say, maybe Python matplotlib code to actually make that plot somehow. And so those are agents that have access to a run environment, maybe a Python interpreter, uh, that where they can write the code to actually give the user, who is an analyst, who's not a software engineer. Um, and so code is for me the most interesting area of focus in the development of agents, maybe for the next year or two.
When it comes to agents or RAG, it's like a pipeline that starts from what's my source documents, what's my information extraction strategy, am I going to use OCR, chunking, embedding, and so on and so forth. So it becomes a system that you have to optimize end to end. Right. So remember when RAG first came out, it was just a bunch of blog posts saying, hey, I think we all should focus on chunking because we tried chunking. We compared chunking to embedding, and chunking seems to matter more.
Yeah.
But now people are realizing this is actually an end to end system that you have to optimize. So, would you say, Jay, that this makes it much more of a formidable challenge for an enterprise team, or that if they want to do it themselves, or they're better off just going with a RAG provider like Cohere and focus on something else? Or do you think that they can just kind of experiment their way through whatever RAG setup they end up in?
Yeah, I mean, it depends on the company and how much sort of capacity they have to throw at this. In a lot of cases, for example, if a company needs a database, they can build one from scratch, but maybe that's not the best sort of approach. They can outsource that, or let's say just acquire it from a vendor. So advanced search systems require access to,
It's just that there's so many kind of each of those steps
yeah,
has 20 choices. So you have this
true.
combinatorial explosion. Then you have to optimize, right? So
Yeah. And companies are in pressure to actually show return on investment very quickly and let's say realize uh, the value of their investment sort of very quickly. And so that's an area where we're using a vendor that sort of specializes for in that uh, area is helpful because technically yes there are lots of different options there of what are the right search systems for this kind of data, how do you have the right connectors to connect the data to the models, how do you sort of shape the workflows and the pipelines and the prompts that are used.
and like you said, query rewriting, re-ranking, all of these things. Right? So
100%. Yeah, these are all sort of so in our educational content, we sort of describe all of these to people. But if you're going to build a system like that, it will take you a year or two or something to get it to an enterprise sort of maturity if you want to build it from scratch. And most companies don't have that time; they just need something that can
and then,
work.
by the way, after you optimize, you realize, hey, we actually need other enterprise features like what you alluded to, security, access
Yeah,
control.
100%, 100%. And so that's why sort of this level of providers sort of create these services.
So in closing, so obviously most companies are not going to pre-train their own foundation model. So it's all about things like agents, MCP, RAG, and post training, right? So post training, including fine tuning, distillation, and whatever else. So how much do you think companies should at least have a basic AI platform that will allow them to do some post training?
I don't think it's necessary for most companies. You can still go far with a state of the art model if you just interact with it on the level of prompt engineering and context management. If it's fairly good at instruction following, like that can get you so far, and you benefit from the rising tide of the models. They keep improving, and you don't even need to change your API, and you can switch between. Uh, and so that rising tide of the models continuing to improve would be helpful and beneficial for you. If you have companies that have that capacity and capability, and they have the machine learning engineers, and maybe that's closer to the core of what their product is. Things like fine tuning, uh, are things where they can sort of distinguish themselves a little bit and have something that is a little bit different, especially if they've tried RAG and prompt engineering and they're not able to get them to sort of use the model in a way that is beneficial enough for their products. Then they can sort of think about things like
The super advanced companies are even doing reinforcement fine tuning, you know?
true, true,
Yeah, I
and
mean, but you have to be somewhat sophisticated in advance. And by the way, I said that was the last question, but this is the absolute last, which is basically obviously the recent developments in foundation models are multimodality and reasoning.
yep.
So, what are you looking forward to on the foundation of models front that you think is still somewhat below the radar? That you think we will start appreciating more in the next 6 to 12 months?
So these two are the big ones right now.
Yeah.
I'm really excited for things that are under the radar that have potential. I'm really excited to see more of these text diffusion models.
So
They're
explain.
so diffusion is a different type of system where you're not generating your outputs token by token like autoregressive transformer does. Um, we've seen it in image generation and video generation. These are all diffusion models where they output the entire image in the beginning, and what they output is just static noise. Like it can look like a static of the old TV with all the white and black dots. But then the model then generates another image that's a little bit more detailed and closer to the prompt. And it does that 2 or 3 or 10 or 20 times, and each time it refines that output and becomes sort of more and more clear. And so that's how image generation works. But then for text, that can take another sort of format where in text, if you're outputting your output token by token, you're sort of already committed to the first two, three words once you're generating the fourth one. But text diffusion models say, okay, I have this general idea that I want to express. Let me have a high, let's say, or an attempt at expressing it, and then have another attempt where I change all of the tokens, not just uh, output them one by one. And those tend to be like some of the early demos for the text diffusion models we've seen. Their output speed is ridiculous, is absolutely incredible. So this can dramatically increase the speed of these models, but it also could pose new interesting sort of paradigms or behaviors for what happens if the model does not have to commit to one token at a time.
Are they can they reason? Like,
I haven't seen demos of them doing reasoning. There's only, let's say, 3 or 4 models that I've seen come, but that's one area that's under the radar that could be sort of promising.
what should the companies or people working in companies listening to this episode think about the smaller models, right? Because most people, at least on the consumer side, they're interacting with these large models.
Yeah,
But who knows? Because they are using multiple models and they have a router. You don't actually know what size model ChatGPT is using. But
sure.
what's the general sense in terms of your expectation for these smaller models moving forward? My sense is that they're going to prove sufficient for most enterprise tasks.
Yeah.
It's not we're not talking AGI, we're talking something specific that you're trying to do, right?
True. Yeah. And if it goes back to your point about on evaluations. So if the company has defined the use cases that they want, and they're able to find the smaller model that is able to, satisfy this, they can deploy or assign that task to a small model that will be cheaper, faster, lower latency, uh, to deploy. And we've seen this across. So the bigger models tend to reason better, tend to be better general problem solvers. But the more you identify the individual tasks that you want, you'll be more and more sort of able to say, okay, these 5 tasks are so well defined that a small model is able to do them reliably enough. And with that, that can come with savings in time and resources and compute. As well. And so, yeah, they're definitely an area to keep your eyes on. I'm really always very excited about small models, and whenever I'm more excited about small models coming out that are capable than large models.
And with that, thank you, Jay.